do an example of Dijkstra's algorithm for you. So Dijkstra's algorithm helps us find the shortest path. And so here we got a home node, which is over here, and we've got the end node, and we want to find the shortest path from home to end. So how Dijkstra's algorithm kind of works is it starts off by assigning like a current distance. So it starts off by saying every other distance is at the beginning infinitely far away, except the home node. And the home node is obviously a distance of 0 away from home. And then it looks at our set, and this is the set of good nodes, right? So I'm going to just give these nodes numbers. So I'm going to call this 0, 1, 2, 3, 4, 5 here, just so we know. And initially it just has node 0 in it. And then it goes, okay, so let's look at our set and let's look at all the edges coming out of our set. And we find that there are 2 edges coming out of the set. There's an edge here and an edge here. And we'll take the one with the lowest distance. So here it's 0, which is our existing home distance, plus 3. And that's lower than our 0 plus 4. So then we're going to add this node. We're going to make this S. Now it's going to be the set 0 and node 1. Right? And then this distance, instead of being infinity, it's now going to be distance 3, right? Let me just change the color of that so you can see that clearly. So this distance is going to be distance 0, and this distance is going to be 3. Great. And now we do the same thing again with this new set. So now we look at all the edges coming out of this set, the set with nodes 0 and 1. And we see that there is a node here, and we see that there is a node here coming out. Sorry, an edge here coming, an edge here coming out, an edge here coming out, and again this edge coming out. Now we again have to look at which is the lowest, and we don't just have to say which is the lowest, like 2 is less than 5 and less than 4. We have to add it on to the distance away from the original node. So we have to take this 1 and add it on to this 2. Take this 3, I mean. Take this 3 and add it on to this 2, and we find that the distance here is now 5. So that would be 5 to get all the way up to this node, node 3. And the distance here is just 0 plus 4. So 0 plus 4 here is going to equal 4. And here this one is going to be 5 plus 3 is going to be 8. And we find that 4 is the lowest of them. So then this node 2 now should also go in here. So S should be 0, 1, and 2. Okay, and so now we need to change the distance on this particular node from being infinity to now just being our 0 plus 4, which is just 4. And now it's also included. Now we updated our node set. So now we have to look at, okay, what are the edges now coming out of our new node set? We have an edge here coming out, we have an edge here coming out, and we have an edge here coming out. Note that we don't want to look at these edges with 6 and 5 because they're still within our set. We want to look at all the edges coming out of the set and into something that's not in the set. Okay, and then here we find that it's again 3 plus 2, which is 5. Here we find it's 4 plus 3, which this here in the diagonal one here would be 4 plus 3 is 7. And then 4 plus, oh, looks like I didn't put a length on this, so I'm just going to let this length be 7 or something. And then so we look at 4 plus 7 over here, 4 plus 7, and that's going to have length 11. And we find, looking at 11, looking at 7, and looking at 5, we find this distance 5 is the least. So then now we add this new node, and this has distance 5 away from it. This has distance 5 away from it. Great. And then we keep going, and we say, okay, well now again, what are the edges that are coming out of it? Oh, note that now our set isn't just S equals 0, 1, 2. S should be equal 0, 1, 2, 3. It's kind of by luck that I've ended up doing them in order. Sorry, not 0, 1, 2, 3. It's kind of luck that I've ended up doing them by order, but it won't always be the case. Obviously, you'll have different nodes in different orders. So here again, now we look at what are the edges coming out. Well, we still have 4 plus 7 being 11. Right over here, we don't need to look at this one anymore because that's within the node set. But we do have to look at this one, which would be 5 plus 2, which is equal to 7. And this one would be 5 plus 7, which would be 12. Okay, so would I take 12, would I take 11, or would I take 7? I'd take 7 because that's the lowest. So then S now has to equal the set 0, 1, 2, 3, 4. Okay, and here I include this node 4 now in as well, so that moves from being distance infinity to being distance 5 plus 2, which is 7. And then I do the last thing again. So now I like 7, and I add it on to this distance 5. 7 plus 5 is going to equal 12 over here, and this one is going to be 5 plus 7 equals 12 again. In this case, it doesn't really matter which one I use because both of them will take length of 12 to get here. So this distance, this very last distance now, is of distance 12, and the shortest path is basically the one that I took to get to each of these. So all the edges that are included in my path were this one, this one, this one, this one, and let's say this one, doesn't matter about the last one. So now my shortest path is actually right across here, and that's going to be 3 plus 2 plus 5, sorry, 3 plus 2 plus 7, 3 plus 2 plus 7, which is going to be 12. Obviously, I could also have gone 3 plus 2 plus 2 plus 5 this way. So that was two different shortest paths available. But the nice thing about this method is that it gives you a shortest path to this node. It gives you a shortest path to this node. It gives you a shortest path to this node. You end up getting shortest paths to every single node. You can kind of stop early if you reach the one that you want to, the end early. But otherwise, you could keep going, and then you kind of have a shortest path to every single other possible edge. So yeah, that's how to do the Dijkstra's algorithm. I hope that makes sense. Let me know if you have any questions. Thanks.